Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
And in taking on the new responsibilities in the interim, went through a number of email inbox transformations, and let's just say that finally getting in contact with Michael was a godsend. So Michael is a PhD student at Wrocław University in Poland. He's leading the Nemerle Project, aiming to deliver a very high-level, modern, object-oriented, and functional language for .NET, and we will hear the details of that project now. Thank you again for heroic trouble.
So hi, I'll be talking about the Nemerle project. So the first slide is what's Nemerle. So it's a high-level static typed programming language. It was designed for the .NET platform since the very beginning. It features object-oriented functional imperative programming. So it is a hybrid. It also features type inference and pattern matching that are mostly seen in the functional languages. We also have a Turing-complete metaprogramming system. That is, we can extend the compiler with external plugins to extend the language itself. So I'll be talking about this feature later. There are two perspectives from which we can judge why we need a new language anyway. So the first perspective is a user or a programmer perspective. So he can combine object-oriented and functional programming in a one source program. Nemerle has good support for object-oriented programming as seen in the .NET. At the top level, the program looks mostly like in C#. It uses the familiar classes interfaces in a class-based language. And methods can be implemented in a functional style, but they don't have to. That is, if a problem area isn't exactly best for functional programming, imperative or object-oriented programming can be used. We started with a language that looked mostly like ML, had a subset of C# feature, but since the beginning we had the functional stuff like functional values, pattern matching, variant types, and so on. Now Nemerle looks, it has this curly braces and looks like C# and includes C# as a subset generally speaking. It has still this functional stuff and macros and more. Yeah. And from a computer scientist perspective, the main reason to introduce a new language is, of course, experimentation. We wanted to experiment with this macro system, metaprogramming system. We also did some experimentation on type inference algorithms for object-oriented class-based languages. Also, we did quite a lot. We learned quite a lot about different trade-offs that need to be made in order for language to work. So, our compiler uses system reflection emit API of .NET, and we stress it a lot. That is, it is a quite big language, and we needed a lot of features in system reflection emit. Some weren't there. Some features. We also stress tested generics recently after the compiler has been retargeted to .NET 2.0 framework. Now we should see some samples. Okay. Yeah. So this is the very first sample. Is it visible? Okay, so this is the very first sample in most programming languages. We have this hello world example. and it looks mostly like it looks in C#. Only the return time is in different place. This is a script to run the compiler and run the executable later. So this is it works. This maybe wasn't a very exciting example, so we shall move to something else. This computes the factorial function. Here is a definition of a local method, local function inside the factorial method. It has accumulator and this x argument. It computes the function as you would expect, and here it is called. So again, we can run it. But Nemerle supports type inference, so this can be removed. And it still works. The resulting binary is exactly the same. And here yet more complicated example to show a concept we use in our type inference algorithm. So here we have a class named foo with a field called myValue of type int. As you can see, Nemerle types are written after the colon. It has a method called barize, which calls system console write. And here we have a macro that is triggered by the $ symbol, and it interpolates values like this myValue into the string. It also works for more complex expression. This is an example of a macro. Another example of a macro is this here, that at the top, that looks like a custom attribute. It generates a constructor for this foo class that initialize all fields one by one. And there's another class, and here we have a local function that have an x argument, and it doesn't have a type specified, and we call this barize method on it. But the barize method is present in two classes, in foo and in cooks. So the compiler at this place has no means to know which type will it be. So our idea is here to defer this typing of this member ACCESS for later. That is, the compiler proceeds, sees this construction of a list of foos, and later it sees this iterator over this list, and then there is a call to this call barize method, and here we know that E is of type foo because our list is of type list of foo, and we are iterating over it. So after compiler sees this, it can take this member ACCESS from a queue and type it properly. And we can run the example. There is warning that cooks was not used. We just put it there, so there are two classes with this barize method. But in general, it works. But if we haven't this iteration here, it bites out with an error because the typing of this barize member on X is ambiguous. So there is another slightly more graphical example. I just took it from MSDN, ran it through our converter. We have a converter that takes C# code and produces Nemerle. I ran it through it. Oh, you can see it even retired the copyrights from MSDN, and we can run it just like it. I have another script because it needs to reference the system Windows Forms library. There's a couple of warnings because our compiler is more touchy about issues like ignored function parameters and so on. So we have this example. It works just like this C# example. Okay. Now I can tell more about macros. So macros are written in Nemerle. They are compiled to DLLs and loaded into the compiler. There's no connection with a C preprocessor or something like that. Macros can transform, generate, and analyze programs. They can also plug into the parser to extend the syntax of the language. They can plug into type inference to extend the way expressions are treated after typing or during typing. They work on syntax trees of expression and types, and there are in general normal Nemerle programs, so they can, for example, read external files or query database. Why would compiler query database? This is a good question. So the reason is that we can have a macro that takes an SQL query. It connects to the database. It tries to execute the query. The SQL server checks the syntax. If the syntax is wrong, the message goes to the user. So the user knows there was something wrong during the compilation. But also, the compiler can check what columns were returned from the query and put them into local variables. So this actually works. There's this select from the employee table. It puts this local variable here with a SQL parameter mechanism. There is no string interpolation. And later we can access columns from the table, first name and last name. Printf was also an example of a macro. This is scanf is another example. Regular expressions, XPath. This is they all can be implemented as macros. Macros can also generate one expression trees from another expression trees, for example, to generate serialization functions, so on. Domain-specific optimization is another example. This macro could check what columns were used and replace this star here with first name, last name. We have an assertion system in Nemerle implementing design by contract. It is also implemented all by macros. In general, any repeatable class level or expression level pattern can be implemented as a macro. For example, design patterns like proxy pattern. Macros are in some sense an implementation of aspect-oriented programming, because you can plug into the compiler and do whatever you want with the code, and macro can be seen as an aspect. It is also possible to implement a set of macros to allow more access to aspect-oriented programming, more like in languages like AspectJ. Okay. So now we can get back to our examples. As you can see, there was this message, and it is here. It was a little modification of the MSDN example. Here we have async is a macro that takes a bunch of code and executes it another thread asynchronically. So it simply sleeps for 5 seconds and prints the message. And the macro looks like this. It uses system threading. We have a macro. Here is a syntax extension. We will use async and then some expression. This expression is inserted here as a local function body. Then we create a delegate from the local function and start the thread. So this just saves these 3 lines of code. There are other macros in the library. For example, one can define macros to work on entire methods, classes. This trace macro works on a method, and it adds debugging output after each line of code is executed. I just uncommented it, and when we run the example, we can see how this tracing works. This is an old laptop, so it will take some time. Okay, here we see first tracing output for this document, and if we add another document, we get more tracing. So this is just an example of what macros can do. They can do much more. Okay, so what about the project? So the main part of the project is the compiler. It is bootstrapping, it compiles itself. It generates and consumes generics, and we recently released 0.9.0 version. This was the first released version for the 2.0 .NET framework. It targets ArcGIS CTP, MS.NET ArcGIS CTP, and Mon 1.1.9. It doesn't work on Rotor because of generics that are not implemented in Rotor. That is, they were implemented, but the API is different. For the previous version worked on Rotor. There are several projects, external and internal, using Nemerle. Sux was an HTTP application server. Development of it was later funded from the grant. This is this converter I was talking about that takes C# source and outputs Nemerle source. Nemish is an interactive Nemerle shell that you can just put code into, and it will execute on the fly. I can show it if I have some time. There is this Asper editor written in Nemerle and using Wix Windows Riddle parsing and lexing tools. We have built a NAND plugin that allows one to use NAND with Nemerle. We also have a code dump generator and this allows for ASP.NET execution. We are currently working on a code completion engine that will allow external application to plug into the compiler and to generate this drop-down menu for IntelliSense, and to generate a tree of classes uses in the source and so on. We are working on IDE integration. We have some Visual Studio plugin, but it isn't really any good shape now. Sharp develop and Mono develop plugins, but neither of them yet support this code completion. We actually reported several issues in system reflection emit to MSDN. Some of them were fixed, some were not. Actually, we think that system reflection emit lacks testing. We ran into several issues that showed that to us. We also reported some issues to the Mono team. There were more issues to report because the runtime is less mature. We have a mailing list for the project with over 70 subscribers. We recently started a web forum. It seems to work pretty well. We have an issue tracker. Over 500 issues were reported. Our web page is wiki-based, so external people can contribute to the documentation. They actually do. We will be starting a free online course around October 1st. I already had a lecture about Nemerle at our institute some time ago, around a year ago. We also made some observation on the performance of the .NET. We're interested in this since the compiler bootstrapped, since it takes a lot of time. Well, not that a lot of time now, because it needs to compile itself 3 times, and it's quite a big piece of software. About tile calls, the type prefix on calls actually makes code run slower, not faster. So this isn't exactly an optimization, but of course it prevents stacked growth, but the performance isn't very good. We also needed to somehow compile functional values. We used a functional object pattern, that is an object with a special method apply, and this works much faster than delegates. That we provide built-in conversion between delegates and our functional values. After switching to generics, the code seems to run faster on the MS.NET platform. It is hard to give hard numbers because bootstrapping the compiler was a quite painful process with several iterations. So it is hard to compare apples against apples here. But it seems to go faster on the MS.NET runtime. It seems to run slightly slower on the Mono runtime. What we have left to do, 1.0 stable release should be soon. The language shouldn't have any more breaking changes. We should do more IDE integration. We're working on it, this code completion project. More community building, and I would like to do some more static analysis on the code generated by Nemerle. Maybe plug it into some terrain improvers, something like that. That would be all. Questions?
Any more questions? Again, dinner time will be a great time to dive deeper. Thank you very much.